Hello viewers, welcome back to another section of my tutorial. In our previous video, we solved several differential equation tutorials. Kindly subscribe if you haven't done so. So we said we should use, by reversing the rule of x and y in the above differential equation or otherwise, find a general solution. So we have 2x minus 4y squared, all in brackets, dy over dx plus y is equal to 0. So let's quickly solve this problem. Kindly watch this video to the end. So now, having such a problem, let's write it here. We have 2x minus 4y squared dy over dx plus y is equal to 0. So once I have this, the problem is saying that by reversing the rule of x and y, so that is the principle we are going to use now. So let's see something here. So at this point, wherever I see x, it becomes my y. So I'm going to have 2y minus 4x squared dx over dy, take note, plus x is equal to 0. I'll have 2y minus 4x squared dx over dy is equal to negative x, like this. So let's see, I'll have the x over dy to be equal to negative x over 2y minus 4x squared. And at this point, I'll make it dy over dx. Here 2 will turn around and it's going to be 2y minus 4x squared all over negative x. So at this point, see what is going to happen here. So the y over dx here is going to be 2y over negative x. Then here is going to, I'm dividing each component. So here is going to be plus 4x, like this. Then I'll bring this one here, I'll get dy over dx plus 2y on x is equal to 4x. And we can see that this is a linear first order differential equation. So we employ the same method we do when you are solving the linear first order differential equation. So once you have this, you know that the next thing to do is to find our integrating factor. Mu of t is equal to e to the power integral of 2 on x dx. That is the integrating factor, which will be equal to e to the power, the 2 will come out, so it's going to be 2 integral sign 1 over x ds, and this is equal to e to the power 2 ln x, where this is going to be e to the power ln x squared, also equal to x squared, since e to the power ln function becomes the number itself. So we have x squared as our integrating factor. So let's quickly go ahead to use this integrating factor to solve for the solution of this first order linear differential equation that we have here. So let's see something. So we have dy over dx plus y over dx plus 2y on x equals 4x plus 2y on x equals 4x. So at this point, I had my integrating factor mu of t to be equal to x squared. So I'm going to have x squared multiplied by dy over dx plus x squared 2y on x is equal to x squared 4x. So we have a condition in first order linear differential equation that whenever the integrating factor multiplies the coefficient of the y, the resulting solution is the derivative of the integrating factor. Hence, this whole expression is reduced as the product of the integrating factor and y, all prime, to be equal to x squared 4x, like this. Now, if we want to find y, the next thing to do is integrate both sides. X squared y, all prime, is equal to integral of x squared 4x, like this. So now, this derivative will cancel, so here will be x squared multiplied by y is equal to integral of 4x cubed dx. And this is simple. This is the same as x to the power 4 plus c. As simple like that. So we have x squared multiplying y. At this point, my y is going to be x to the power 4 over x squared plus c over x squared. So y will simply be equal to x squared plus c x to the power negative 2. And this is the general solution to our differential equation here by reversing the role of x and y. This is the end of the video. Thanks for watching. Kindly subscribe and don't forget to like.